This conference will now be recorded.
Okay. Good evening, everyone. Welcome to the workshop on microservices, Docker, and containers. This is Roshan here. This is something about me. I have around 13 plus years of experience in IT, mostly into performance engineering, Java and Python development, and also in automation as well. As far as my cloud credentials are concerned, I am certified architect associate. I have been doing automation as well using Java, Python, PL SQL, shell scripting, and Selenium. And I'm currently working as a principal SRE. Yeah, that's about me. Um, and this will be the agenda of our discussion. We'll be covering this. Uh, to start with, we'll understand what is this monolithic applications. We'll understand what this monolithic application mean, what is the advantages of it and what is the disadvantages of monolithic applications, and what is this microservices. After understanding the monolithic applications, we can understand this microservices better. We'll understand its architecture, how it is designed, and then characteristic, and again its advantages and disadvantages, same as what we'll cover in monolithic applications. And then we'll understand the differences between microservices and monolithic applications. uh, we'll understand where these microservices run, what's the runtime environment, and obviously we'll look into container engine, one of the popular container engines, Docker. And using Docker engine, we will create containers that we will understand. And basically, the runtime environment for microservices are containers, and we're going to create containers using Docker engine. We'll also understand the Docker installation, how to install Docker. I'm going to demonstrate this in one of the Linux VMs, Ubuntu. I have provisioned this VM instance in AWS Cloud. So it is a fresh operating system I'll be working on. And then we'll understand some common Docker operations. So like how to pull, if you can look at my diagram here. So this is the Docker hub here. I'm going to pull the image and post. We'll understand what this image means. So this is like a very basics to get you up to speed on about all those things: monolithic, microservices, containers, Docker. This will be very basic. So if you do not have any background, it will benefit you a lot to lay a good foundation to understand more complex concepts like Kubernetes in your day-to-day activity. So this is a very basic, we'll be covering here fundamentals. So that's very important to have fundamentals strong. So we'll be focusing on this workshop. So this is the agenda of our discussion. Okay. Okay. To start with, uh, what is monolithic applications? Okay. So currently you guys are working on, most of you guys would be working in three-tier applications. When I say three-tier applications, I mean to say presentation layer, that's your web server. Mostly you'll have some kind of a web server here. And then your application layer, that's the business logic, some application server, and the data layer, your DB. Okay, so mostly you guys are using, mostly 90% of the IT having this kind of architecture, three-tier applications, we say. Okay, so and what this monolithic mean? When I say monolithic mean, I'm talking about this application layer here. uh, and in later point of time, I'm going to discuss about the microservices, and then I'm going to discuss, let you know how these microservices differ from monolithic. So just focus on this application layer here. Okay, in monolithic applications, all my application components, all my business function components are tightly packed, okay, and deployed as a single unit. So when I say tightly packed and deployed as a single unit, I mean to say, suppose I'm having a bookstore application, any application, and I have, suppose, these kind of modules, business modules, accounts, shipping, payments, or inventory. So when I say tightly coupled, so it means that if I'm writing any code for the accounts, any functions I'm writing for the account section, I'm free to use the function in my other modules like shipping, payments, or inventory. So that's what I mean to say when I say tightly coupled. So I can reuse the code, any function, what any developer, suppose I am building this accounts application, and developer has written full code of accounts, and they have used 10 of the functions. Like the function would be the logic, business logic. So I'm free to use that business function, that function in any of my modules in the monolithic applications. So that's what I mean to say monolithic. Currently, you guys also would be working in monolithic applications. So when I say monolithic applications, you will have one application server, and all the code of your application, all the business logic of your application will be hosted in that application server only, and they are tightly coupled. We'll understand more about it when we'll understand microservices, how they differ. So these are two important concepts here, monolithic and microservices. So this is how monolithic are designed, are architecture. Okay. So what is the disadvantages of it? This particular diagram here. So the advantages are very important here, like very few, but are important. Uh, the code reusability, right? I can reuse the code. Whatever the code I'm writing in accounts, I can reuse the code in any of the modules. I do not need to rewrite the code here. And other advantages are they are deployed as a single unit. Okay. And ID support. Uh, Suppose I'm developing in Java, suppose, and I'm using Eclipse to do that. So I can integrate all my modules, accounts, shipping, payments, and inventory in the Eclipse. So ID support is provided for the monolithic applications. These are the few advantages of monolithic applications, but if you look at the microservices craze in the IT industry, and if you look at the disadvantages, why these microservices are picking up nowadays, and if you look at the disadvantages here, you'd understand that why people are preferring microservices than monolithic applications. It could be often very large, right? And technology dependency on initial decision. So when I say technology dependency on initial decision, I mean to say, suppose when I am trying to develop my application, I started with accounts, one module, and I decided to develop this in Java, suppose, or Node.js, any language. Okay. I then, if for the second subsequent modules like shipping, payment, or inventory, I don't have an option to choose any other programming language. I have to stick with the same initial decision. I have to use either Java or Node.js, whatever I have selected initially. So that is one of the disadvantages here, and we will understand this how microservices lead here and how things are developed in microservices. So once we understand both the things, you guys can understand these things better. Implemented using single development stack. So as I mentioned, so again, it is the same thing. Frequent deployments are not practical, obviously. All are tightly coupled, right? Even for the small bug, suppose a person has found a bug in the account section, a small bug, minor enhancements. They're not going to deploy that bug at that moment exactly, okay, right at that moment. We need to wait for some quarterly release or those kind of thing, because for that single bug to get implemented to fixed, I have to deploy and build the entire code, and that is exactly not feasible in the case of monolithic applications. For the small bug, I cannot rebuild and redeploy my entire code. So frequent deployments are not practical. Need to scale the entire application stack. One of the major disadvantages is this. Suppose as we are performance engineers, right? Most of us, I'm just imagining that we are into somewhere related to the performance testing. Even if we are not, if you're from development background, so performance should be there in your mind always when you're writing any code. So suppose when I say that the need to scale entire application stack, I mean, suppose there is a user requirement for accounts is more. for one particular business module, I'm observing that the more number of users are trying to are accessing this accounts module or any search module or any shipping module, any one particular module. If there is user are accessing more, there are more user load. I cannot scale that particular business function. I have to scale the entire application stack. So you guys must be doing it. If you want to scale up the application server, any because of any one module, suppose the user requirement, you did a load test and you found that you are resource constrained on only one accounts, any particular business function, the response time is not good, and you found that it is the reason is that you're not a resource, your content on the resource contention is just, you have the resource contention, you don't have the enough resources to accommodate that many user load. You come to this conclusion, and only because of only one transaction or few transactions in the entire transaction list of your response time, either do it using LoadRunner or Jmeter or any other tool, okay, new load, any other tool. So you have to scale up the entire application stack. You have to increase the entire application server memory or CPU, whatever. So just because of one particular business function limitation, because the user requirement are more, and you have to scale the entire application stack. So that is one of the important, I would say, the disadvantages for the monolithic applications, and that's what we will target. So whatever we see the disadvantages here, and that will work in favor of microservices. Basically, the main reason is on the architecture, how the microservices are architectured. So that we will be seeing in the next few slides. So when I say microservices, what I exactly mean? I mean creating smaller and multiple component services which are built to handle a very specific concern. And multiple services, multiple such microservices make up your application. So coming to the next slides, I would just like to go a few slides back. So when I say microservices, what I'm trying to do, this is one tightly coupled unit, right? I'm going to break this down. In microservices architecture, I'm going to break this down into 4 different groups, different units: accounts, shipping, payment, inventory. And I'm going to reduce the dependency among these guys. Across all these modules, I'm going to decrease the dependency: accounts, shipping, payments, and inventory. Once I do that, I get a lot of benefits. The first benefit is that if any one of the modules goes down, suppose one of the modules, accounts, stop working, it will not impact my other modules. The entire application will not go down. But whereas in the case of monolithic, even if one of the modules are not working, means I'm talking about one of the functions inside that, one of the code functions inside that is not working, that function may be called at multiple places, right? And if this guy is the problematic here, I have the problem here, it may impact my other modules as well in the case of monolithic applications. That's why I'm going to break down my monolithic applications to microservices to reduce such kind of issues, to mitigate the risk, so that all my guys here are independent. That's what the bottom line is, the microservice architecture, and we'll understand these things better in few upcoming slides. Okay, so that's what I mean to say, creating smaller and multiple component services which are built to handle a very specific concern, and multiple such services make up my applications. So that's the entire concept of microservices. So if you want to design an application that is multi-language, so I would come to that, the benefits of it. What's the merits of having microservice architecture? Easily scalable, easy to maintain and deploy, highly available, and that minimizes failures. Then use the microservice architecture and design and deploy a cloud application. In case of microservice architecture, each microservices owns a simple task and communicates with the client or with microservices by using lightweight communication mechanisms such as REST API, obviously. So, and if I have multiple such microservices, so there has to be a mechanism so that these microservices communicate with each other. I see a question from Bharti. All the API services components are integrated into a single unit. Is it correct? I don't exactly understand your question. We are trying to break down the monolithic applications, okay, and trying to make it a smaller unit, and so that they work autonomous. I'm trying to create dependencies, and each of these microservices will be the REST API. To call that microservices, to use that microservices, either you will have a web application if you have a UI or a RESTful API. That's how it works. So I'm not very much clear with your question. So you can rephrase your question after I finish with my session. I'm going to answer your question, Bharti. Thank you. So, okay. So let's understand this architecture here. So when I say architecture, so let's focus on this guy here, this part here. So let's focus on the same application server. Okay. Here in this case, what I'm trying to do, uh, one of the microservices I have developed in Java. Okay. Another microservices I'm developing in Python. Another microservices I'm developing in Go language. Can you see the difference here? In the case of monolithic, it was the initial decision. If I have went ahead and developed my application using Java or Node.js or Python or Go, I have to stick to that decision, and all other business components will be in the same language. Though I may have benefits, performance benefits, if I go ahead and write my application or develop my application using other language. So that is the one of the important aspect of using microservice architecture, because my two of the microservices are independent and they communicate using RESTful API. That's how it works. And I can develop using any language. I need not use the same language what I've selected for one of the microservices. Okay. See, web service and microservice. See, when I say microservice, I'm trying to, you should understand this concept, Vinod. So when I say microservice, I'm trying to break down my monolithic application. Okay. It can communicate using web service or RESTful API. That could be anything. Okay. It is not like web service and microservices are siblings. Okay. Web service or RESTful API can be siblings, but not microservices. In when I say microservice, I'm trying to just break down my big monolithic applications into smaller pieces. And that smaller pieces can communicate using web service or RESTful API. That is a different part. Okay, I hope you understand the difference now. When I say monolithic, so try to talk about monolithic and microservices. Monolithic can also use web service. Can also use REST. Can have the REST API calls. Monolithic applications can have these things. Even microservices can have web service calls or REST API calls. They can. So both can use these RESTful services. But where the difference is, you should think about difference in the monolithic and microservices. I'm just trying to break down my same application I'm trying to break down into various microservices so that I reduce the dependency. I don't have the common code. I'm not reusing the code, so that even if one of the module goes down, my other services are working just fine. Suppose I'll give a better example. You use so many mobile applications like Swiggy, you have Ola, Uber, whatever. So they have divided their entire thing into various microservices. Okay, so even if suppose your notifications goes down, if notification this business function is not working, it will not bring the entire application down, because they are developed in microservices. So if one of the services are going down, it will not impact the other services. You can still order your food, you can still book a cab. So that is what the important point is. So multi-language, easily scalable, easy to maintain and deploy, because I have broken down my big application into various components. So it's very easy to maintain and deploy, highly available. So even if one of the modules, one of the microservices goes down, it will not impact my other microservices. It will not make that other microservices fail, right? That minimizes failures. So that those are in the merits here. Okay. Okay. Let me just. Okay. So let me go over this. So here, microservices enable you to design your application as a collection of loosely coupled services. So what word I used with monolithic application? Tightly coupled. And in case of microservices, I'm using the word loosely coupled. That's the important point here. And if I need to scale one of the, like suppose this is my search. Suppose I'm talk. Let's take a real time example. Let's talk about Amazon.com. Okay, what you do, what most of the user do, what type of activity they do on Amazon.com. They try to search. We search the products. The search functionality is highly used. Out of all those functionality, booking an order, clicking on, like we are performance engineers, we have use cases, performance test use cases, right? If you look at all the use cases, you would find that search is the mostly used use case in a retail application. Any retail application, Flipkart, Walmart, or Amazon.com, any retail application, search. People search for many products, they research, and then finally they order one. So payments, it's not like they will be putting more load on the payments. It's obviously important to tune that microservices as well, but search is the most widely used functionality. Why I say so, and what's the important and what's the relevance here? So suppose container kind of microservices one is my search functionality. This guy, when I say search functionality, the code to which is doing my search action is written here, all sorts of code. Okay. And these are other modules. Okay. Let's take any other modules. So if I see that this particular microservices users are accessing more, means the users are calling more. What I can do, I can just scale this container, this microservices alone. I need not scale the entire application stack as what we have done using my monolithic application. In case of monolithic applications, if we have found a bottleneck for one of the transactions or few of the transactions, we would have found that it's the resource contention, we would have scaled the entire application stack, all the business logic, all the business functions, entire application server in case of monolithic application. But here in the case of microservice, I can specifically scale up more containers. I can have this microservices one, it is the form of container. Okay, I would tell you that microservices run in container. We're gonna see that how microservices can be how the runtime environment for the microservices are containers, and how to create containers, and how to host microservices. I'm going to demonstrate that. I have one instance. So this is my instance, just to show you. This is my instance here. I have just provisioned that in AWS console. Okay, I'm going to show you. I'm going to demonstrate everything here. So we'll be seeing that. Just so wait for some time. So I was mentioning that if I want to scale this container, I can have multiple instances of this container alone to accommodate all my user load, to all my extra load, what I'm observing. I need not scale up other containers. So that is what in the favor of microservices. Think from a performance point of view. I need not scale up the entire application stack. I am able to reduce the cost because I have not scaled the entire application stack. I have just scaled up this container. I have created more such containers to accommodate more user load. That's it. Huge achievement, a huge deal here in the case of microservices. Okay. That's what I'm trying to do here. I'm trying to create. So in my first slide, when I started with my monolithic applications, I had the same business logic, same application components, accounts, shipping, payments, inventory. It was tightly coupled, but now they are autonomous. The words are autonomous and specialized. They are not dependent on each other. If suppose accounts are not working, suppose if one of the modules are not working, it will not let my other application down. uh, no, it can, you can have this microservices anywhere. Okay, you can have, it is not like just about the cloud. What is this cloud? Again, you are getting confused with the very basic question, like Vasant. What do you mean by cloud? Cloud is just the hardware or the resource which I am not owning. Someone else is owning. Amazon, AWS is owning. I am just asking them, can I use your resource and I will pay you something. That's what is the cloud. Hardware is the same. Even if it's on-prem, on-prem means what? You are owning the data center. You have purchased all the servers. You can use this not just in cloud, anywhere in your on-prem environment as well. Okay. Yeah. So when I say autonomous and specialized, okay. Uh, so autonomous, when I say microservices, I mean to say that now accounts and shipping, payments and inventory are not tightly coupled. When I say not tightly coupled means I'm not using the code of my accounts in shipping. There is less dependencies among all these modules. That's what the intention is. And one microservice is specialized for that particular activity. This Ravi, so your question is microservice nothing but API. See, it is not like just that. Okay, API, what in the monolithic application also you can have an API. So think in that perspective, that when I say microservices, it is not a service like web service or RESTful service. Okay, don't think that in that way, because we have used the word service here. Okay, uh, you can have API in monolithic applications as well. Okay, so think in that perspective, that you are breaking down your bigger code into smaller code. Rest, everything is same. What you are doing in monolithic, I'm doing the same thing. The all those web service or RESTful service, I'm going to create the same thing. It is just a smaller code. Okay, I'm talking in a layman term. It is just a smaller code. Suppose if I'm using all these four modules and I'm trying to write one code considering all these four modules, my code size would be bigger, multiple pages. Now now when I say microservice, I'm going to break this down. So I have come up with, so this guy would take 2.5 page, this guy would take 2.5 page, this guy would take 2.5 page, this guy would take 2.5 page of code. And I'm trying to create dependency. Maybe I may have to write 3 pages for each, because when I'm trying to reduce the dependency, I may have to rewrite the code. So that I do not call the function from shipping. Accounts should not call any function which is being written in the shipping. Accounts should have all the functions in itself. So I may have to rewrite the code here. The code size could be bigger, but the advantage is that if it will not, even if one of the modules goes down, it will not impact my other modules. So that's what the The real deal is here. Yes, architectural change. Yes, yes. So I'm trying to break down my applications, and when I say break down, I can use any language for any of my microservices. Okay, I need not be stringent about using same language. I'm not forced to use the same language here. Okay, so that's the important deal here. Okay, so what is the advantages here? Okay, advantages are very huge. Flexible scaling. I have already mentioned that if I am observing that I am resource content, if my resource contention is there, in general, I can easily scale one of the microservices. I need not scale the entire application stack or the server itself. Okay, I can create multiple containers, multiple such containers to accommodate more load, okay, to accommodate more users. So flexible scaling, easy deployment. I have broken down the code. Now it's 5. Suppose let's take this example. I have one monolithic applications. I have broken down the code, and now I have 10 microservices. And if I have a bug in one of the microservices, I can deploy just that microservices. I need not deploy or build the other 9 microservices. So that's why I mean to say easy deployment. Technological freedom. So I can have one of the modules in one language or in other. So I am free to choose technology, language differently for the other microservices, other business modules. I am free to choose that. Reusable code within one microservices. Within one microservices, when I say within one microservices, I can reuse the code because this is one unit accounts. I can also club accounts and CP can connect, and I can come up with one microservice. That again depends on my decision. How many microservices I want to create. So suppose if I do see that accounts and payments are having more same code, suppose 40% of the code are same for accounts and payments, I need not create two different microservices. I can club these two and I can create only one microservices because the code base is 40% same. If I create these two as different microservices, that 40% of the code will be, I have to write it here also, I have to write it here also. So that's not a good decision. So how many microservices to come up with, that again depends on a decision, depends on this decision. So do we have more like same similar code? So depends on the business logic that you are trying to create microservices for. So again, how many microservices, that's a high level decision that architecture has to take, that once they are breaking down your monolithic to microservices architecture. So that's the architecture that question on that front. Okay, I'm going to come up to this question. So rest assured, I'm going to finish something here. Maybe your question will be cleared. Okay, so I'm going to take up the questions in some time. So flexible scaling. Now we understand that easy deployment, technological freedom, reusable code. So when I say reusable code, within the same microservices, I can reuse the code, but I have to be independent between two microservices. Okay, within the same microservice I can reuse the code. Resilience, right? So that's the important deal here. So that's what the entire intention is. So even if one of the module, suppose I have an issue with account section or any module, I've just taken this name, uh, I have issue, this account is not working properly, it will not impact my other modules. That's the main deal here. My application is still functional, still working. It, your application as a whole is not down because of one just bug. Okay, only one issue, your entire application is not down. You would have seen that in your application, because of one bug, uh, your entire application goes down, right? But not in the case of microservices. it will just impact that particular logic, that particular specialized service. It will not bring the entire application down. So that's the resilience it gives microservices. So huge advantages here. It doesn't mean it do not have, it doesn't have the disadvantages. It does have. Okay. uh, as I first mentioned, duplicate code. Let me tackle this first, because as I mentioned, right now I'm trying to make these two guys independent, right? I don't want to use the function what I have written for accounts in shipping, though I need to use that, but I have to rewrite the code here also, because I want to make these guys independent, right? For resiliency, right? I want to achieve that. So I may need to duplicate the code. Okay, again, we can again reduce that. So the drawbacks are not like we cannot work on on those drawbacks. If we observe that there are common codes, okay, common functionality, common code, we can club. Suppose, as I mentioned right already, that 40%, suppose that if I do see, if I create two microservices, two different microservices, accounts and payments, and I'm observing that there are 40% of the code is same, so only the 60% of the code is different. So why to do that? Let's club these two services and create one microservices. So that's a good decision. Okay, so again, so decisions will be taken at the high level, at the architecture level. How many microservices to come up with, on what basis? It has a lot more basis. Okay, I'm just trying to make your fundamentals strong here, but again, decisions are taken on a lot of things. Okay, here. So how many microservices to create so that code duplicacy can be minimized? Because we are at the end, we're trying to reduce the dependencies among microservices. Microservices can communicate with each other through REST API calls, but again, I do not want, if one of the microservices is down, others should also goes down. I don't want make dependencies. I want to reduce the dependencies to have to achieve higher resilience. I hope you guys are understanding the basics here. That's what the intention is. Spawning. Okay, spawning. So when I say spawning, if I have too many of containers, right, it sometimes it becomes difficult to manage. If I have too many microservices, so suppose you have a monolithic application, you have broken down into hundreds of microservices, and a lot of then after that you have similar containers, like, okay, similar containers of similar type to accommodate user load. It sometimes it becomes difficult to manage if you have too many microservices. So best thing is to have only to have a significant number of microservices that you can manage. You should not overdo that. So the disadvantages are not like you cannot manage, okay, but these are the disadvantages that you should take care. You should take care before you create your microservices. Maintenance, obviously, if you have too many microservices, uh, obviously it will be difficult to maintain all. So make sure if you are doing that, you have a significant number of microservices. And network performance. I'll talk about in the cloud what we do to achieve high availability. We do that in different AGs, okay, availability zones in different. I'm talking about in AWS language. In AWS cloud, we use AZs, availability zones. We do deploy microservices in different AGs for high availability. And what it does, just for the high availability, and what it does, if the distance increases between the client and the microservices, performance it may impact the performance. So make sure that the regions what you are selecting and the availability zone you are selecting, it's near to the end users. Okay. So as I mentioned, right, so all the disadvantages can be worked out, but these are the disadvantages. So it's not like microservices are are the best thing. Yeah, they are much better than microservices, but it doesn't have the disadvantages. No, it has disadvantages, but these things can be worked out. So that's about it. So I hope you guys have understood the difference here, the basic difference between monolithic and microservice architecture. And this is the difference here. Uh, Now, if you have understood the monolithic and microservices, you can easily understand this. The processes are tightly coupled here and run as a single service. Okay. Here, one service per process. That's what the intention is. I'm trying to break down the code so that I have one service per process, right? Uh, Adding features becomes more complex, obviously, right? If you want to add something, okay, you have to use the same language, same technology, what you have selected before initial decision. But here, adding a functionality is a cakewalk. I can just create another microservices, okay, and I can just architect it, network. I just need to do networking between so that the microservices can communicate with each other. It's easy to create a new service, new functionality, integrate in the case of microservices. Adds risk for application availability, obviously, right? So if one of the modules goes down, it will bring down my entire application. That's why I'm talking about microservices, so that I'm easy to maintain and it has the high availability, right? It can be updated, deployed, and scaled rapidly to meet demand, right? Uh, Someone asked me to elaborate spawning. So spawning, as I mentioned, right? Spawning is like if you have too many of microservices, too many. Sorry, if you have a lot of microservices and you need containers, right? Microservice, the runtime environment for microservices are containers. Suppose you have too many of containers of one kind, and so it becomes difficult to manage. So spawning is that. So you need to be careful. So if you have too many containers, it becomes difficult to manage. So that's one of the disadvantages. So so again, so as I mentioned, right? So that's the meaning of spawning. Too many of microservices, too many of containers. That's the meaning of spawning. So as I mentioned, right? So disadvantages are not like you cannot manage, you cannot work around, you can. Okay. So yeah, so that's the difference between monolithic and microservices. Okay, so we have completed the one part here. We have understood the monolithic application, microservices architecture, what's the difference, advantages and disadvantages for both. Now the next question is, where do we run these microservices? That's the next question. Where do we run this? I can run in physical servers, I can run in virtual servers. I can also run in containers. Anywhere I can run. Okay. So let's understand this. Physical servers, I'm talking about one complete server. Okay. I have not done the virtualization, and there also I can host microservices. After I did virtualization, I created multiple VMs from in the same physical server. There also in the VMs I can also host, I can run microservices. But where the best microservices are best run in containers, the best advantages of running microservices are in containers. So when I say containers, right, what do you exactly understand? Containers we can host in VMs. Again, we can create containers in VMs. So when I say EC2 instance, right? So this is one of the EC2 instance I have created here. If you look at this is my AWS console. Okay, I have created one EC2 instance just a few minutes before our workshop. So when I say EC2 instance, I'm mentioning one VM. When I say physical server, that's the bigger box. A lot. So consider a huge resource, huge number of CPU, huge number of memory, everything scale, and that is what the physical server mean. I can create multiple VMs in one physical server as per this diagram here. Okay, and when I say VM, I'm talking about one EC2 instance. Okay, virtualization, right? So the EC2 instance that I have created in AWS, that's the VM. So I am going to create containers in the VM. That is where I'm going to create containers there. And in the containers, microservices run. And I'm going to demonstrate that. I'm going to show you how this works, how this works world functions. Okay, containers, microservices. If things are new to you, so feel happy about it. You're gonna learn a lot here. But if you know already about it, good. You're gonna learn something more. Okay, so that's the containers for you. Okay, let's understand containers now. What is this container? We have understood physical server. Physical servers are nothing but consider a bigger box with so many CPUs and huge RAM. Okay, now I have broken down this physical server into various VMs, and now I can have in all these VMs I can have different operating system. And similarly, this is my one of the VMs I just created. So this is my private IP here, 172.31.42.11. This is the same private IP because I'm using this container, this instance here. You can just see that this is the same private IP here, and this is the public IP of this container. So this container, this sorry EC2 instance. So this is a VM. This is a EC2 instance. This is a VM, and that's the public IP of this EC2 instance, and that's the private IP. And you can see the same detail here. I've just connected through PuTTY. PuTTY is a software you can use in Windows to connect to your EC2 instances that you create in AWS. Okay, I hope you're aware of it. Basics of cloud. Okay, I'm going to change the font of it so that you guys can see it better. Okay, okay, I hope you guys can see this better now. Okay, so I'm gonna create this. So let me cover first what I'm going to cover. Okay, so let's understand this container first. What is this container? So the runtime environment for microservices are containers. Okay, that's the simple definition. What is a container? So the runtime environment for microservices. And let's understand the difference here. The VM. Okay, I have created one VM, one EC2 instance. Okay, in AWS console. And let's understand the difference between a VM and a container. This is from the very basics, guys. Okay, so if you do not understand, if things are new to you, feel free to ask question because this is from very basics. So let's understand the difference between VM and container. So in the case of VM, in this particular diagram, hyper infrastructure, when I say infrastructure, I'm talking about the physical server. Okay, this physical server. So this is my physical server. Okay, I have installed one software, some kind of hypervisor software, which will help me create which will help me to create virtualization. It which enable me to do virtualization, and I can create multiple VMs. That's what I'm trying to show here. Okay, from the physical server, I'm creating multiple VMs here. So that's what I'm trying to show here, that I have this physical box here, physical server, and I have installed one software called hypervisor that's allowing me to do virtualization. Okay, there are virtualization softwares from VMware, a popular one. Okay, now in this particular diagram, this one particular this box here, I have three VMs. Let's call it VM A, VM B, VM C. In one VM, I have one operating system. Okay, and I have binaries and libraries of that operating system and one application. So similarly, I have created one VM. This is my VM, one VM. I have logged inside that VM and I have used Ubuntu software. Okay, Ubuntu. That's the Linux. I can use Red Hat. I can use any Linux flavor. I can also use Windows, but I'm going to demonstrate this microservices in Linux. So I have just provisioned one Ubuntu operating system here. I could have done Red Hat also. There are a lot of options I get when I provision this cloud console. Let me just show you. If things are new to you, cloud, let me just show you that if I launch this instance, if I create one instance, I get so many options. I can create Red Hat, SUSE Linux. I get so many operating system options, Windows, okay, Ubuntu. So I have used this 16.04 long-term support, this operating system to create my VM here. That's what I'm showing you here. Okay, this is my VM workshop I just created some time back. So this is my VM. Okay, yeah. Let me just, okay, so now I have an operating system for my VM, binaries and libraries which comes bundled with the operating system, and I can also install some application. Mostly what I have, suppose if I'm using a 3-tier application, suppose, okay, uh, monolithic application, then I can use app A as my web server, app B as my my application server, and app C as my database server, and I can have my complete application stack, and I can have my application running. In the case of container, let's understand this, what happens. So let's focus that this is one VM. This entire box here, I am showing this as one VM. Okay. Inside the one VM, I can create multiple containers. So you can see this, I have app A, app B, and app C, 3 containers. This is the infrastructure here. Now this is the VM, okay? VM infrastructure, not the physical server infrastructure. This is the VM infrastructure. And I have installed, this is my host operating system. My host operating system here is Ubuntu, right? As in the case of this example, I'll be taking this example here. So this is my Ubuntu, okay? I can just find this operating system of this guy here. But as you can clearly see, this is my Ubuntu. Okay, I have options, a lot of things to. I can just demonstrate that if I do uname uh, hyphen a, you can just see that I'm using Ubuntu here. So you can just see this is my Ubuntu, and this is 64-bit operating system, and that's what I have it here. Okay. And I'm logged in as Ubuntu user. So I'm Ubuntu user right now. That's why you're seeing here Ubuntu, because I am Ubuntu user. One of the default users when you create this instance is Ubuntu, and that's the private IP of this instance. Okay. Yeah. So what I will do here, I will install Docker engine. Okay. I'm going to install this Docker engine, and what it will do, it will create multiple containers. It will allow me to create multiple containers, container A, container B, container C. And as you can notice here, I don't have a guest operating system here. I have just the host operating system. Okay, so in the case of VMs, it virtualizes at the infrastructure level. Okay, here, see VMA, VMB, VMC. But in the case of containers, it virtualizes at the OS level, this OS level. Now I have app A, app B, app C. What I can do, I can have app A as my web server, app B as my app server, and app C as my database server, and I can have my application running. So that's the advantage of containers. Okay, let's understand this now. So characteristics of the containers, very lightweight. It will spin up very quickly. Once I will start demonstration, you will be realizing this. That's how it works. Okay, then you can relate this better. It boots up in seconds because it doesn't have an operating system here. To boot up a container, it's very fast. You will notice that it will boots up in just fractions of second, 1 second or 2 seconds. I can have my entire application stack running. It takes fractions of disk and memory. It will take very less footprint. I'm going to demonstrate that it will take very less memory. Advantages: portability, resource efficiency, obviously, right? If I'm going to take fractions of disk and memory, so resource efficiency is at its peak, right? Best. Isolation, all the containers will be isolated from each other. And better performance, obviously, if it boots up in seconds, it doesn't have the disadvantages of a guest operating system. It will take very less time to boot up. Even if it dies, the containers can be recreated, right? So you can spin up another containers very quickly, and also it can be scaled very efficiently. So that's, and when I talk about scaling, basically talking about container orchestration engine, okay, like Kubernetes or Swarm. Okay, yeah, I'll come to that. See, Docker is a container engine. Docker will help me, Jay. Docker will help me to create containers. Okay, see, that's why in this diagram you can see this, that once I install the Docker engine. So Docker engine is what? Container engine. So don't say Docker. So basically Docker is one of the container engines. Okay, so basically, so Docker is that popular that it has replaced the word container engine. Basically, Docker is a container engine. I'm going to install a container engine on top of my operating system. So this is my instance, right? I'm going to install Docker engine here. Okay, a container engine, which is nothing but a Docker. There are other container engines as well, like Rocket, Podman. There are other containers engine also, but Docker is very famous. Okay, so I'm going to install a container engine, and that happens to be Docker. Docker will help me to create containers. Kubernetes is container orchestration engine. Container orchestration. When I have multiple containers, so Docker is there to create containers, and Kubernetes is there to manage the containers. So that's the basic difference. When I have multiple containers, Kubernetes will help me manage the all the container. If like auto scaling part, as I mentioned, right? Suppose this is my web server. App A is my web server, and if I do see that there is a demand in the user load, okay, CPU utilization of this container is now crossing 60%, 70%. We can set a limit that if your CPU utilization goes above 60%, create more containers, such containers. So who will do that? Kubernetes. So that's the container orchestration engine, Kubernetes. There are other container orchestration engine as well in the market. Kubernetes happens to be the most popular, mature, and stable, and it's from Google. A lot of benefits of Kubernetes. That's why people are learning Kubernetes. They want to learn Kubernetes. So Kubernetes is there to manage containers. Docker is there to create containers. What all Kubernetes does: auto scaling, load balancing. So there are a lot of features of container orchestration engine. Okay, so that's not the scope here, agenda here. I just explained you. Revati has asked something, but you are creating container inside the VM. Yes, that's how you get the best out of it. Okay, see, Revati. So when you have why did you create VMs? The idea of creating VM was to use your resource efficiently. Okay, what happens in the physical server back in 1980s? Okay, or 70s, when this software was just started. Okay, we had just a little KB application in one physical box, one physical server, bigger box. A lot of resource was wasted. A lot of resource was wasted. I had just tiny little application at that point of time, and they used to host in the entire box. That's it, only one server, only one application in the entire box. Can you imagine the resource which was getting wasted, unutilized? That's why when this virtualization came into picture, we were able to utilize the resource better in a much better efficient way. We created 10 VMs out of this physical server, 10 VMs, and now I can deploy 10 applications. In the case of physical server, I was just deploying one application, but in the case of virtual server, from the same hardware, I just used one virtualization software, VMware software, to create virtual VMs, and now I can host 10 different applications in the same box. That's the power of VM. Now we have further breaking down into containers. Inside one VM, I can have multiple containers. So the idea has always been to utilize the hardware resource in an efficient way. That has always been the idea, and that's what the intention is. We want to utilize the resource, the hardware, because I need to purchase a lot of hardware, right? If I need to scale up to host any application, that has always been the key factor, because that's where the cost goes. Most of the cost goes. I want to pay less, right? I want to host more application. I want to have better efficient utilization of the resources. I want to achieve my user load in paying less, right? That's the entire the whole idea is. So now when I say containers, now inside only one VM, I can create multiple containers. I can I can host the entire application stack. In the three-tier application, I was using three VMs, right? You guys are using, right? Three VMs. One for the database server, one for the web server, one for the application server. You're using three VMs to have three-tier application. Now, inside one VM only, I can create three containers, and I can host my, I can have my application running. So that's the power. That's been the case always. So that's where you get to utilize your resource efficiently. Okay, so let's understand this. We have just half an hour. I'm going to demonstrate a few things, because that then you'll it make more sense. So what the question, as per the diagram, does app A, app B, app C will be deployed to the same container? No, same VM. App A, App B, App C are three containers. I'm going to deploy them in the same VM, not same container. Okay. So as I mentioned, right, one container will have one application. That's what I started with. Microservices is a specialized autonomous service. So one microservices means one container. It will be used to host only one application, smaller application, not monolithic application, smaller. Yeah. Okay, so I would take this question later. Okay, I need to finish this hands-on. If not, it will not, my agenda will not be complete. I'll take the question. So if you have questions, stay after the session when once we are done. So let me take the hands-on first, and then I'll take up the questions. I'm free to extend for the questions, but not for the session here, because people are expecting to have all this agenda done within the time. So I'm going to take the hands-on now. Okay. So that's the concept of containers. And as I mentioned, right, so let's understand the container architecture here. So containers are virtualized at the OS level. So this is my OS. So I have a VM. I have one host operating system. In the case of me, I just put in this current example, I have this Ubuntu here. I'm going to install one container engine that happens to be Docker. It could be anything else. There are multiple container engine out there, Rocket, Podman. I will be demonstrating using Docker. After I install Docker engine, container engine, I can create multiple containers. That's what I'm going to demonstrate you. and let's understand how this works, this world functions. So that's what I'm going to demonstrate. Benefits: very lightweight, boots up in seconds, takes fractions of disk and memory. That's all the benefits of the containers. Okay, if I have 10 containers inside the one box, so you can just understand how much fraction of disk and memory it takes. And just to mind you, this VM has just one CPU. You can just see that I have just one CPU and I have just 1 GB of RAM I'm using. Okay, that's the list. You can get it in AWS console. Okay, uh, I'm going to take the question. You can keep it writing. I'm going to take that question later now. Okay, I'm not going to look at the questions now. I'll get distracted. So currently I have just one CPU for this VM and I have just 1 GB of RAM. But I can create multiple containers inside this. So you can understand how much less footprint these containers have. You can just relate that part. Okay, I'm going to create multiple containers inside this VM. And you can just look at this. One CPU for just one CPU and just 1 GB of RAM. That's it. Okay. Advantages, I think I have discussed this: portability, resource efficiency, isolation, speed, and scaling, right? Container engines, there are popular container engines like Docker and Rocket. I'm going to demonstrate using Docker. I'm going to install Docker now. As you can see, I don't have a Docker installed here. If I would have Docker installed, you would have seen. Let me do one root user. I am currently Ubuntu. Let me be root user first. Okay. Now I'm root user. You can see that I'm root user. Okay. Let me just see if I have the Docker installed. I do not have the Docker installed. Okay. I don't have the Docker installed. To install Docker, I'm going to run this command. There are other ways also to install Docker. This is a simple way of installing Docker. I'm going to use this. It will install a Docker engine, but not the latest one. Someday, some other day, I would tell you how to install the latest Docker. But if you do this, it will install Docker. Okay. Okay. So this is the if I have to compare between virtual VMs and containers, right? So this is the VM I'm talking here, and this is the container. So let's understand the difference. This understanding of this difference is very important here. Understanding what a VM mean and what a container mean. So when I say VM, I have used one virtualization software. You can just see I have this physical server. Can someone go on mute? I do hear a sound. Can everyone can please go on mute? Thank you. Okay, so let's understand this. So I have this VM here and the container here. In the VM, in the case of VM, I have used one. I have used this virtualization software called VMware ESX. Okay, and now I can create virtual VMs, virtual VM1, virtual VM2, virtual VM3. I can create multiple VMs once I have this virtualization software. In the case of containers, so what does it signify? That VM virtualizes the hardware. That's the important point, and that you should understand. Containers are not here to replace VMs. Okay, containers are here to use the VM resource efficiently. You should understand this part. Okay. So containers are used to use the VM resource efficiently. So VM virtualizes the hardware. You can just see that I'm virtualizing the hardware here. But container, I have the infrastructure here and the host operating system. I'm going to install one container engine, and then I can create multiple containers. So in this case of containers, containers are virtualizing the operating system. That's the important difference between a VM and a container. So VM are virtualizing at the physical server layer, the hardware, but in the case of containers, containers virtualize at the host operating system. So that's what the important point is. And containers can run within VMs. We're gonna run that. We're gonna demonstrate that, and we're gonna see that. Okay. Let's understand this part now. How this container works. Okay. So I need to have Docker engine installed. Once I have the Docker engine installed, okay, what I can do, I can pull this image. I can pull the image. There is something called Docker Hub. Okay, there is something called Docker Hub. I'm going to show you that there is something called Docker Hub. In the Docker Hub, what you do, you basically have images of your application, images of your application component, images of your microservices. You have that. Okay. And what you can do, and you have a lot of images. Suppose I can find an image for MySQL. Okay, I can have an image for MySQL. See, this is the Docker official image. If I install Docker engine, okay, let me install Docker engine first. Okay, then I'm going to talk about this. To install Docker engine, what I can do, I can just type this command and it will install Docker. Okay, in my Ubuntu. Or let me do this command a better way. So that's what I'm going to. I was about to tell you some other day, but I decided to tell you this time only. But this will not install this command here. This will install Docker, and you will get a version of, after you install Docker, you will get a version. But now you will not get a version as I have mentioned, right? It will install Docker, but this command will not give you the latest Docker. Okay, so to get you that, there is a command. I'm going to share that with you. You can use this command. Okay, let me copy this. Okay, let me paste this. So what you can do, I'm just going to this website, this link, and I'm trying to download this. Okay, docker.sh. Once I do that, you can see this. I have got this downloaded. Okay, in this you can see this is my current working directory, home Ubuntu. Under home.ubuntu, I have this downloaded now. Using this command, I have downloaded this. I can share all the commands with you after the session. Once I do that, I can just install Docker by using sh, uh, doing sh and using this shell script. So this is basically a shell script. Once I hit this, it will install the latest Docker. It will take some time. I should have done first, upgraded the package. Okay, I should have done that. So whenever you create VM, whenever you create EC2 instance, the first thing you should do is to upgrade the package. I will do that after this command. Okay, let it complete first. It is okay. It has started installing. It is a shell script. You can get inside this shell script to see what all it does. It will basically uh, pull the latest Docker from the Docker Hub. Okay, it will take some time and it will install Docker. So basically what I'm doing here, if you want to relate that with my diagram here, I am installing a, a container engine. This is my VM and host operating system is Ubuntu, and I'm installing one container engine called Docker. Okay, that's what I'm doing it right now, and it's done now. If I do Docker version, what you can see this. I have this client and I have this engine. So Docker has two things: client in an engine. So I have installed Docker now. Okay, so I have Docker engine. So that's two command to use. I'm going to share all the commands with you after this session. Okay, whatever I'm using it right now, I can do in history and I can just ping you all the command. I'm going to do that. Or I could have done sudo apt install docker docker io, because this is a Ubuntu, so apt will work here. So that's what I'm going to do, apt update, because this is an Ubuntu, right? So this is a Debian flavor of Ubuntu, so apt will work. In CentOS, yum works. Okay, so I'm going to use apt update now. It will basically update all my packages. So it's like Windows update. You do that, right? Once you install Windows for the first time, you do Windows update, right? So that it install all the packages and all the yeah, like anything, all the possible latest updates. So now I have this. It has upgraded all my packages, so I'm good now. Okay, and I can Docker version is installed now, and that's what I'm going to demonstrate this. So I have Docker engine. I have got this installed now in my VM. So, and there is something called Docker Hub, where the images, container images, okay. When I say container, I'm talking about microservices images are stored, officials. Okay, that's what I was showing you, that this is the image for MySQL. If I hit this command, Docker pull MySQL, I can see that this image will be downloaded. Okay. Similarly, I can install other operating system also, like Fedora. Fedora is another operating system, right? What I can do, I can install this guy, Fedora, on top of my Ubuntu. So if you have to relate with my diagram here, I am trying to create a container for Fedora. Okay, and I can customize that container. I can install Java inside that container. Okay, let me just show you. If things are new to you, you're gonna like this. Okay, let me do one thing. So as I showed you, right, this is the command I'm going to run, Docker pull Fedora. Okay, I just copied this. Let me take this, clear this. I just did. Let me show you one thing. Docker images is the command to see the images that you have. So currently I don't have any images. And if I do Docker ps-a, it will give me all the running containers. So I don't have any containers running as well. I don't have any images. I don't have any containers. So that's what I'm going to uh, use this. I'm going to pull this Fedora operating system. Like, you know that Fedora is an operating system. So I'm trying to create. Similarly, you can create a container for MySQL. You can create a container for HTTPD, your web server, Apache 2. So similarly, you have a lot of options here. You can create a container for MongoDB. Okay, if you want to have MongoDB a container, you can use it. Okay, you just need to issue this command. You can also have Jmeter as a container. You have an image for Jmeter as well. So you till now you guys would be have installed Jmeter standalone, right? Using in the Jmeter org site and downloading Jmeter. What you can do, you can just go there and use this command to install Jmeter as a container. You can also install Jmeter. So a lot of containers are out there. Okay, HTTPD. So again, this is a web server. Okay, this is the web server from Apache. Okay, I can use this to have a container for a web server. I'm going to do that. Okay, also, so let me first do that for Fedora. Okay, so Docker pull Fedora. Once I hit this, what it will do, it will download the image, Fedora image. I'm basically downloading the Fedora image onto my VM. So if I do Docker images now, you can see that this is the image. Can you see the size of the image? It's an operating system, mind you. It's an operating system, and size 175 MB. The why I downloaded this, because the reason is that I want to show one more thing. I take your attention that in the case of Docker, in the case of container, I don't have a guest operating system. Okay, I can have the same application running. I can have suppose in the case of VM, I have three VMs for my three-tier application. I have a web server, one app server, one database server. In the case of container, I can have app A as my web server, app B as my database server, app C as my application server, like same configuration, same application stack. But in the case of VM, I am using three VMs. Three VMs means three operating system. But here I'm just using one operating system. That's a big deal. That's a big deal. I'm just using one operating system and I can have all my application stack running using Docker engine. And I will use the binary and library. Suppose app A is my web server. Okay. I just downloaded the Fedora, right? Suppose app A is my Fedora. Let's they take that. Fedora is the operating system, but basically Fedora is using the binaries and libraries of this host operating system also, because both are Linux. So it is not behaving like app A is, in my current example, app A is Fedora, but it is not behaving like an operating system because it is using the binaries and libraries of the host operating system, which is Ubuntu here. Okay. So I have now, you can see this, I have this Fedora, and what I can do, I can run this image to create a container. That's how this next diagram was, is like once I download, once I pull, so I have used pull here to download the image, and I got the Docker image. Now you can see that I have Docker images as Fedora, one of the Docker images. Similarly, I can use Docker pull HTTPD. This is my web server from Apache. Okay, web server. Okay, I can host web pages here. I can do this. It will download another image. Okay, now if I do Docker images, I should see both the images. See, I now I see HTTPD as well and Fedora. So I have two images now. So this is the web server of size 138 MB. Okay, and if I want to run this guy, okay, if I want to run this Fedora, what I can do Docker run -it -d Fedora. Okay, I can just do this. IT is for the interactive mode. Okay, IT is for the interactive mode, and D is for the daemon. Okay, once I do that, it will become a container. See, this is my container ID. If I do Docker PS, you can see that I have one container running. So this is my one of the containers. So inside the VM, I have run one container, Fedora container, one operating system. And what I can do, I can go inside the container and I can work. How to go inside? To do that, I use the word docker exec. This is the command to go. IT followed by container ID. Okay, so this is my container ID and followed by bash. Once I do that, did someone notice that I am inside till now, till this point? This is where I was under the root. I am the root user and I am on the instance, EC2 instance. Now I am inside. Once I hit this, I am inside the container. Can you see that? This is the container ID. I am inside the Fedora operating system. If I do ls, I get this this is now the Fedora. Okay, I'm not, if I do Docker version now, I will not get anything because I'm not at my host level. I'm inside the container. I have gone inside the container. This is what I want you to realize, that I am inside this app A now. I am no more in the my EC2 instance. This is a very important thing to understand, that if I do Docker version, I will not get this Docker version because Docker version is not installed in Fedora. Docker version is installed in host EC2 instance, host operating system, not in the container. What I can do, since this is this Debian, right? This Fedora is CentOS operating system. So if I want to upgrade, suppose this operating system, apt will not work, yum will work. So I can do an yum update. See, if I do apt update, it will not work because apt is a Debian command. Okay, so I have to use yum update. So what it will do, it will download all my packages. Okay, so that's what I'm trying to realize you, that make you understand that that's the difference between I logged into the EC2 instance, I logged into the VM, I created the container inside the VM. Now I'm inside the container to operate. I'm just upgrading one of the operating system that I am using as one of the containers. I can customize this container. I can install my web server. If I want to install Java, if I want to install my web server here, and I can save this container. I can save this container, and I can also push that container as an image, and I can push that to Docker Hub, and I can use that. Okay, so that's the beauty. Okay, I'm going to demonstrate one for HTTPD also. So this session may extend for 10 to 15 minutes. So if you guys are learning, I hope you would not mind extending the session. I don't mind sharing my knowledge. Okay. So what I have done now, I am inside the container. I have just upgraded the Fedora operating system, one of the containers. If I do an exit, I am back to my host. I am no more in the container. Okay, and what I can do, I can customize this container. I can install whatever I want. I just upgraded the package. I could have installed Java, I could have installed web server, I could have installed something. And what I can do, I can commit this container. How to commit means taking a snapshot, saving this container, and I can have my own image, customized image, so that I can use it at a later point of time. To commit this, I can use Docker commit. Let me just do Docker ps-a first. Okay, this is my container running. Okay, this is my container. This is my container ID. This is my Fedora image, and this is a random name which has, I can change the name also. Leave that for now. So what I can do, I can commit this image. To commit this image, I need to use Docker commit. Okay, followed by container ID. Container ID is this. Suppose I have installed something, I have customized my one of the containers as per my requirement. Okay, now I want to save this image, so I can give this image Fedora new. Fedora new. So this is my new image now. So it will take some time because it is taking the snapshot, it is saving my image. So you would see the difference in the size now. So I have the image now. If I do Docker images, I should see 3 images now. Okay, I should see Fedora was already there. HTTPD pulled. Now I have this Fedora new also. Can you look at the size, guys? Here I upgraded the package. I just did that. And how much is the size now? 535 MB. So my operating system size is just 535 MB. I could have done something more with that. I could have customized my container. I could have taken the one image. Now I can push this image to my Docker Hub account. I can have an account in Docker Hub. Similarly, I pulled it, right. I can have an account in Docker Hub. Currently, I have an account in Docker Hub right now. Uh, I can push this image to my account. Okay. my whatever the customization I have done, and then I can pull it later whenever I need it. So I have done that sometime before pipeline and web app. So I can pull and push the image. Okay. So that's what I was trying to explain you, that I can um, uh, once I have the Docker image, I can run that Docker image to create a container. I can stop the container. I can simply type Docker stop container ID. It will stop the container. I can delete the container also. There are a lot of activity I can do. So suppose I have this container, right? Docker ps hyphen. If I just, this is the command to look into the Docker ps hyphen a. If I do that, this is my container for Fedora. I can stop this container. I don't want this container running now. So I can just type Docker stop container ID. That's it. It will stop the container. Now, if you type Docker ps hyphen a, it will not show you anything. It is just exited. Okay. This is the status now. If I do Docker ps will only show me the running command, running containers. So you will not see anything. Docker ps hyphen a it gives everything, all the running stopped containers. Okay, that's why when I type Docker ps hyphen a, I'm seeing this. But ps will just give me the running containers. If I do Docker ps, nothing is running right now because I stopped it. So easy to, so you can just see how easy. When I say it boots up in seconds, fractions of seconds, that's what you can see here, right? As the characteristic of the container, I can easily boot in fractions of second, right? That's the power here. And I can do the same thing for HTTPD, okay? I can do, suppose I have one more image, right? See, I have 3 containers now. Let me just demonstrate that for HTTP. This is the web server. So what I can do, I can just Docker. I have already, let me run it. Okay, let me run. This is the web server. Okay, so what I'm going to do, I'm going to do a port mapping also. I'm going to show you to host a web page, real web page. Okay, so let me run this container first. Docker run -it -d, not -d, -p. This is p for the port mapping. I am this particular web server runs in port 80 at the host. But if I want to use the port with container, I have to map it. So 83 port of the container will map to 80 port of my host. This is how port mapping works. So this is a web server. I'm trying to run it on port 83 of my container, and it will map to my port 80 of my host. -d is the daemon followed by the image name. Okay, so this is the image name. So once I hit this, this became a container now. You can just see if I type Docker ps, you can see that this is my container now. Okay, and this is port 83 it is hosted, and 83 of the container, it means 83 port of the container. See, I have HTTPD as the container only, right? I can host this is the web server HTTPD. I can host the web page on the container. So I can only access the web page on 83 port. But actually it has to run on port 80 of the host. So I have to map it like this. 80 of the host. So what it does, if I enable this port, let me just do one thing. I have to make one change in the security group here. I have to enable, that's the AWS security thing. I have to enable port 83 as well for the security group. Okay, security group is this. I have to I have to open the firewall. Okay, there is something called AWS thing. I have to enable the port here. Custom. Let me use HTTP custom port. I have to custom TCP. That's fine. It will work. So I have to open port 83. Okay, I'm opening for the world. This is a CIDR, and I'm opening for HTTPD. Okay, web server. This is just for the namesake I'm giving. So this will allow me incoming rules, means it will allow 83 port to run. And once I save this, so I have this 83 added. 83 port I have to add. If not, it will not work. So now if I go to EC2 instance, if I go to my EC2 instance, and if I go to my public IP, okay, if I'm using public IP, and if I do 83, see, it works. So I'm able to host a page, and this page, where it exists, it exists in the container. So this is anyone can access this. I'm going to ping this. You guys can check this if it works or not for you. It will work for everyone. This is the public. This is my public IP. Okay, I just use the public IP. Uh, this is the public IP. Okay, 54, 93, 235, 47 of my server here, and 83 port I have opened it because I have web server on the container, right? And I have to open this 83 port to work it. And this web page, whatever you are seeing here, right? It is hosted in this container. I can go inside this container and I can locate you to this web page. Okay, that will be there. So that is how it works. Okay. One important thing that I would like to highlight this, the footprint. I mentioned that this guys takes very less footprint. So now you have understood how microservices, the runtime environment of the microservices are container, and how containers are created in VM. So you have understood those two things. One important thing that I highlighted, that it takes fractions of disk, right? How do you know that, right? So very important command for performance engineers is the Docker stats. So I have one container right now running, right? Let me do one thing. Let me create two containers. Let me, Fedora was also running, right? Let me start Fedora also. I'll have two containers for me. That's it. Just want to have this. Let me use Docker images. So let me Docker run -it -d Fedora. Okay. So I have see it's the operating system. Now you can just see the time it takes to boot up, right? Fractions. So now I have two containers. One is my web server, one is my Fedora operating system. Two containers running. So I was talking about that it takes fractions of disk, right, and memory. So as a performance engineer, this is a very important command, Docker stats. If you hit this, you get the statistics of all the containers that's running. So currently, I'm not doing any activity on any of the containers, right? So CPU utilization is 0%. Memory, this guy is taking 5.85. This guy is taking 1.98 out of this 1 GB of RAM. Memory utilization is this. If I start hitting this web page, right? Suppose I write in my Jmeter script, I automate this. I just hit this page with 500 users right now. You will see that it will spike up. Spike up all the memory utilization and all the CPU utilization of my this container. So Docker stats is the very important command that as a performance engineer you should always look into that to understand the footprint of your containers running inside the VM. Okay. So that's all about it today, and I'm going to share all the commands that I have used today with you guys. You can save it and practice on your own. Okay, you can just save this. So I just provided all the commands that I have used today. So that's all about it. I wanted to discuss today as part of this workshop. Uh, yeah. Now I can take up the questions if you have. Yeah. Thank you, everyone. Yeah. So that's about the workshop. Yeah. Feel free to ask me any question if you have. Yeah.
Hey,
I
did you
hope
create
you guys.
normal EC2 instance?
Yeah, please come again.
Or did you create like Ubuntu EC2 instance?
Right.
Yes.
I did that.
Okay.
So this is my EC2 instance I created. Yeah. Yeah. So as I mentioned, right? So yeah, cloud is my place to where I work. So I created this instance. I have to configure the putty session, PPK file, then only I can access this thing. Yeah. Any more questions?
So I have my application installed on Tomcat server, and there are multiple applications installed which interact with each other. In
Okay.
that case, how would Docker help?
So Docker will help. You should have one image for Tomcat. As simple as that. So if you have
Okay.
installed, if you have installed Tomcat as a standalone, you can use this Tomcat image. And let me just show you. I'm going to create one Tomcat server myself. I just downloaded the image of Tomcat. Once I run this Tomcat, and once I specify the ports and all, it has to run. I can show you this Tomcat is up and running. So that's how Docker helps. Docker helps to create containers, and you can have container of any kind. I can install MySQL database itself. I can install MongoDB. I can install Tomcat as my application server. I can install HTTPD as my web server as a
So
container.
you mentioned that for each microservice, we need to have a container. But in my case, in Tomcat container, I have hosted 2-3 microservices that interact with each other.
That's fine. Yeah. So I have also mentioned that again depends on your decision. You can also club two microservices to create one container. Means you can, if there are more, see, you have a Tomcat server. That's the application server for you. So you can host any number of your application server. So in your case, you have hosted two microservices. You can do that. Again, it depends on the decision. How many microservices you would want.
Okay, okay.
So I have this Tomcat now. I have just installed, I have just downloaded these Docker images. So you can see that I have Tomcat also. Once I run this Tomcat, as per the specifications they have mentioned, what port and all. Once I run this, once I hit this guy, I would have all my Tomcat running in that port 8080. So this is the port mapping for you. So 8888 of the container will map to 8080 of my host. Once I hit this command, you would see Tomcat up and running for 88 in 888 port. I just need to go to the security group. I need to just enable this port, and you will see Tomcat up and running. And then you can deploy any of your WAR file. Yeah.
Okay, thank you.
Sure. Okay. Any more questions, please? No.
Yeah, hi, Rasan, Gaurav here.
Yeah.
I need to ask, for example, to get any microservice project work. So in the requirement gathering phase, means what we can tell the client that where is the importance of performance testing for these application, and or any other non-functional testing requirement. We can showcase them, and then we can get the work from them actually.
See, again, it is the same thing. So microservice is just your one of the functions, right? Functionality, your business case, your application component. So the way you deal with your client, suppose you have a monolithic application, you are trying to discuss the performance test scope in general. Suppose let's talk about monolithic application. The approach doesn't change. Approach is the same. So for the monolithic applications, if you have identified a use case, a business case, performance test scope, performance test case, that, and if you're able to justify your client that it's the critical use case that you need to performance test, if not, it may impact the business. So same thing goes for the microservices. You just need to understand what that microservices is created for, what does that microservices perform, what is the performance impact if that microservices fails. So you just need to justify that thing, the same approach what you have for monolithic. So microservices is just the sub application, subset of your main application. You just need to understand what does that microservices do. That's it.
Okay.
And then you can explain them the importance of that microservices and that you need to get it tested. Yeah.
So here the client is generally during the means if it is they are using the cloud services, they can do the dynamic scaling and they can say that we don't have much use of the performance testing, and with the help of developer they can do that. So how can we say that that there is a need of performance testing and it will be critical? It will help to save their revenue also for if they do that performance testing. So that is the thing, this because we are using the dynamic scaling there. So that will means increase the system capacity, and then the performance will improve of the system in the cloud
Sure.
model.
I understand your question. I understand your question and concern basically. So we do have this functionality, load balancer and auto scaling group, where automatically as per the CloudWatch alarm, as per the trigger point, either on the CPU or on the memory, you can
Yes.
get one more instance up created. That is right. But the
Mhm.
point is how many you would like to have in buffer. Suppose you need to provide a minimum and max of the instances, or if you're talking about in the microservices world, and if you're hosting pods, so if you understand Kubernetes, so basically you need to understand that how many pods. So pods are nothing but it's a some basic unit in Kubernetes, and inside the pod containers are. So when we talk about pods, basically when we talk about Kubernetes, we talk of pods, not containers. Basically one pod will have one container mostly, okay, and there could be cases that one pod can have multiple containers. So let's not have that discussion. So you need to benchmark basically as part of performance testing. You need to benchmark that how many pods can be accommodated in one VM. That you have to test, that no one
Okay.
could tell if you want to use your resource efficiently, right? So depending on your microservices, how big it is and what it is performing, how complex it is, there could be a case that if you're using a microservices A, one microservice, let's name that A, only four such pods can be accommodated in one VM. There is microservices B also. Suppose 10 such pods can be created, can be accommodated in the another container. So it's your performance testing responsibility to benchmark and make them understand that how many such pods can be accommodated in one VM, so that you can get to use the resource efficiently. Or though you have auto scaling feature and all those things in Kubernetes, yeah, developer can do that implementation of Kubernetes. But
Mhm.
if you want to utilize the resource efficiently, you need to know how many pods can be accommodated in one VM, so that you know what is your threshold, when to create another instance, another worker node, another EC2 instance. That's you as part of your performance testing is important. So that's where your role comes in. And basically nowadays, if you're a performance tester, you better be learning these all concepts called Kubernetes and Docker containers and cloud. You need to know all these things, because think yourself as a DevOps performance engineer. Try to fit in that role. Just a suggestion from my end.
Yeah.
Don't be a performance tester or engineer now. Try to be a DevOps performance engineer, which can perform both the activity, uh, uh, DevOps plus performance. So then you will be in good demand. Yeah. Thank you.
Sir, I have a
And
question.
Yeah. Sure.
Hello.
Yeah, yeah,
yeah,
I can
The
hear you.
yeah. So,
yeah.
will we cover auto scaling of like a scaling of containers in this syllabus of yours?
Yeah. No.
Like,
Okay. So I have a regular sessions. Okay. I have a regular session with Isha. You can talk to Kumar Shar. Let me
mhm.
show you that site. Okay. There is my new training. I have um, a regular course. Okay. Uh, Let me just go to that link. Uh, Okay, so this is my course. Okay, this is my link of that course. You can go over the syllabus of this. Okay, and I'm coming up with a course. Okay, which will talk about like I think from 13th of Jan. Okay, uh, it will be in the evening slot. Every month, I come up with one in the evening and the next month in the morning. So again, you can join any of my courses. For now, this is my current course that I'll be coming in. And if you look at the syllabus here, I am covering cloud computing, AWS cloud, in depth, then Linux command line. If you are very new to Linux, so you'll be, my tagline is get as comfortable with Linux OS as you are with Windows. So you get to learn Linux command line as well. First, cloud computing using AWS. I'm explaining everything there. You can just look over the syllabus here, everything in detail, and you can also join the demo session. Demo session is also
Yes,
scheduled.
but container can be scaled, right?
Containers can be scaled.
Containers
Yes.
can.
Yeah, that's what Kubernetes is for.
Okay.
Kubernetes is for that only. Containers can be scaled. You need a container orchestration engine like Kubernetes or Docker Swarm to scale up your container automatically. Auto scale. Containers
Okay.
can just not be scaled, it can be auto scaled. Both are two different
Yes.
things. Yeah. So it
Yeah,
has to
yeah.
be auto scaled automatically without manual intervention. Yeah, it can be. So this is my course.
Uh,
So you can talk to Kumar sir here, Mr. Kumar here. That's the number. You can get it from the site. Okay. Uh,
yeah.
yeah, you can talk to him. Okay.
Okay.
For,
Okay.
for
Thank you.
further details. Sure.
Roshan, I have one question regarding the security testing. That is also
Okay.
for the part of non-functional testing. So what
Yeah.
is the means because it is a critical in the cloud-based architecture. So if a microservice, what are the rules? What are the requirements related to security testing we can identify there?
See, security testing it is a non-functional requirement, but it is a different domain only.
Okay.
It is a non-functional testing, but it is not like performance. It is a different team they work on. So it all talks about the vulnerability of your application. So when I talk about security, so how vulnerable your application is. Can anyone can hack in to your application? How vulnerable? So that's all a different kinds of non-functional testing. I basically take up the performance aspect of it.
Right.
I mostly deal with that, not the security aspect of it. Yeah, to be clear. Yeah, but it is under the
Okay.
non-functional requirement. Yeah.
Mhm.
So this is the number. Okay, this is the number of Mr. Kumar. You can get it from the site. Okay, you can contact him. This is his number. Okay. So note down. You can go note down this website, or you can note down this number.
Sure.
Yeah.
Hi, Roshan. Question. Is this course for performance engineers or DevOps?
This course is for both. This course is for both, but mostly inclined to performance engineers. I'm trying to bring performance engineers to understand the where they need to go. So basically, if you ask me, it will also help the DevOps engineers. But the current course, what I'm talking about, it is mostly, it is 100% for the performance engineers, but it will also help all the DevOps engineers because of the course content simply. Cloud computing, any DevOps engineers has to know one cloud service. So I'm taking up AWS, and from very beginning, so from very scratch, the way I do is from very scratch. So cloud computing, then Linux command line if you're new to Linux. So it is for both actually. If you're either you are if you're a performance engineer, you if you want to learn that, and if you're trying to start your journey from DevOps, you have to have this knowledge. So this is a common thing that a DevOps engineer and a performance engineer has to know. Docker, Kubernetes, and CI/CD pipeline. So both. And one more thing is missing here, CI/CD pipeline. I think it's not updated here. Okay, so it is that also. Okay, CI/CD is also is covered here.
Okay,
So
thank you.
CI/CD pipeline, continuous performance testing is covered here. So if I have to, yeah, show you. Okay, so okay, it is not here. Yeah, so it is for both basically. Okay, yeah, okay, I don't think so. I have it here. That's fine. Okay, so it is for both. Yeah. So one thing is missing here, that CI/CD pipeline. I also
Oh,
cover
yeah.
CI/CD problem with the website. Yeah.
Okay.
Sure. So that will be a demo session. You can join the demo session for this course. If you would like to join this course, there will be a demo session on Wednesday. Okay, this Wednesday. If you are in the group, you will be notified. This Wednesday, this is the time, 9 p.m. to 10 p.m. Same time, there will be a demo session, 9 p.m. to 10 p.m. So you can join this session to understand more about the course. Yeah. Okay, I think we are good, right? We are good, and we can wind up. Uh, Thank you, everyone, for joining. I hope you learned something today. Yeah. Thank you.
Thank you.
Thank you, everyone.